Okay, so this is the next part of this lecture on nonspecific host defenses. We've already talked about physical defenses, and now we're going to talk about the specific chemical defenses. And what we mean here are chemicals and enzymes that are present in body fluids. All right, some examples of chemicals and enzymes that are found in body fluids include earwax, which is called cerumen, and this oily substance you find in skin called sebum. All right, so sebum is this oily product that you find on skin. One thing you don't want to do is you don't want to use too harsh a soap. So if you use a soap to feel clean, what will happen is you take all this oily substance off. You will indeed feel clean, but then you'll have dry, scaly skin. But don't worry, the company that sold you that really harsh soap is willing to fix your problem. And so you can buy a low in lanolin, for example. Lanolin is a product that will provide moisture to your skin. And of course, what you don't know about lanolin is it's a product of the wool industry. And lanolin is sheep sebum. Okay, so if you want to go and lather yourself with sheep grease, you just use some oil or lanolin or any kind of lanolin. It's better to not use a harsh soap and just to use your own protective sebum, just keep the amount down. Cerumen is earwax. And of course, these provide an oily or waxy barrier. In the case of earwax, it's also very acidic that prevents the colonization by bacteria. In terms of enzymes, there's an enzyme called lysozyme. This works specifically against gram-positive bacterial cell walls. All right, so it's, in a very general sense, kind of like penicillin in terms of its specificity and its target. Its mechanism is different. What it does is it cleaves the chemical bonds between the molecules that make up that cell wall, but you don't need to worry about that. The place you find lysozymes are in tears. In case you wonder why there's not any bacteria growing in your eyeballs right now, at least not in large numbers, this is one reason why. It keeps those Staphylococcus organisms out, even though they're all over your skin. And lysozymes are also found in the GI tract. The next chemical or enzyme that's present in body fluid is also an enzyme now. So lysozyme is an enzyme. These guys are just waxes or oils. And that would be lactoperoxidase. All right, focusing on the peroxidase first, So peroxide, enzyme ACE, so this makes this very highly reactive chemical H2O2, or hydrogen peroxide. This is highly chemically reactive. If you dump it on bacteria, you can kill the bacteria fairly quickly just by non-specifically modifying the carbohydrates, the lipids, the proteins, and most importantly, the nucleic acids and nucleotides. Very, very potent damaging substance here. The lacto is a reference to the fact that it originally was thought to be in milk. There is a related enzyme that's found in milk, so I'll include it. There is a peroxidase inside milk that does provide some protection. It's also found in, again, tears, just like the lysozyme is found in tears. And it's found in saliva. All right, the fourth and final chemical or enzyme that is present in body fluids is lactoferrin. Ferrin, again, focusing on the second part, this tells you what it does. Ferrin is a reference to ferrous and ferric, and ferritin all are have something to do with Fe, which is the chemical symbol for iron. Lactoferrin binds iron. Which we mentioned before in terms of anaerobic respiration and being an oxygen acceptor. But anyway, so lactoferrin binds iron. Iron is absolutely positively required by organisms to grow. All right, so if there's no iron, then there's a limitation on a bacteria growing and undergoing cell division and making a new bacterium. So binds iron, and by doing so, it limits the availability of iron for bacterial microbial growth. And this has the longest list, so it's found again in tears, in milk, saliva, and we're adding one now, airways. All right, so if you look, there's this kind of not so clever crescendo here where we start out with tears and gastrointestinal tract, and then we keep adding to tears, milk, tears, and saliva, milk, tears, saliva, and now airways. So I rearranged them specifically so you can see this where they are. Now, in addition to these chemicals and enzymes that are present in body fluids, there's also antimicrobial peptides that can be secreted and found on the skin. All right, now I'm not entirely sure that, going into nursing you need to know all the antimicrobial peptides. There certainly were a bunch in the book. The one that I remember specifically are the defensins, so that's the only one I'm going to require that you know. My recollection of defensins comes with a lecture that I heard once on frogs, and specifically frog skin. So you define defensins in lots of different places, but the one thing that I remember about defensins is they're actually found on frog skin. And this is in the context of a talk where someone was doing some drug discovery, and they were interested in seeing if we can't just sort of take a lesson from a frog and its defensins and come up with a better antibacterial agent. So that's how I remember this in a talk on antibacterials and cystic fibrosis. But anyway, so the way the defensins work, so they're found on frog skin, your skin, and bodily secretions. And the way they work is to make pores in biological membranes, specifically in bacterial cell membranes. And of course, if you make a biological membrane porous, then bad things can come in, good things can go out, and you have all kinds of mayhem. There I sound like an insurance commercial. Okay. All right, the next category of chemical defenses are things that you find in serum. Now, serum is the watery component of blood minus the clotting factors. So it's basically found in blood plasma and serum. Again, the only difference being presence or absence of clotting factors. So serum or plasma and you see now how we're taking a different direction. The first category is the chemicals and enzymes that are found in body fluids. Those are largely secreted. Antimicrobial peptides found in the skin and secretions were largely secreted. And now we're talking about these nonspecific chemical defenses that are found in this internal compartment, which is blood plasma, lymph, and you know what's in blood plasma, lymph can diffuse then into the interstitial fluid that bathes every single cell in your body. So there are two things I want you to know here. One are acute phase proteins. These proteins, there's a number of them. They're made by the liver. And they include C-reactive protein, and serum amyloid A, and C-reactive protein and serum amyloid A function is what we call opsonins. And what opsonins do is they target and coat bacteria. So this is a bacterial cell just sort of minding its own business. So I'll just make it a little rod here. Here we have our bacterium. And the C-reactive protein and the serum amyloid A know what a bacterium looks like non-specifically based on, the components of the cell walls and the cell membranes. And so then it'll basically, these C-reactive proteins in the serum amyloid A will then coat. So here they are floating around free in the serum, and then once they get close to bacteria, they will bump into the bacteria, they'll stick to the bacteria. These opsonins. The process of coating a bacteria with the opsonins is called opsonization. And once opsonization has taken place, then you have your Pac-Man cells, your macrophages that come along and phagocytize the bacterium because they now recognize these proteins on the outer part of the bacteria, and the fact that they're all stuck to the bacteria. These are recognized by a macrophage. Which is a descendant of a white blood cell. A macro means large, phage means eater. And so once you have this opsonin-coated bacteria, then they're recognized by the macrophage, and then you have this process of cell eating, which is called phagocytosis. So this is what happens the first time you encounter a bacteria, any bacteria. There's no memory, it's just that you have these proteins that will specifically bind to gram-positive and gram-negatives, and thus allow macrophages to be able to identify these as being something that doesn't belong, consume them, phagocytosis, and then break them down. Now, in addition to the acute phase proteins that are made by the liver, there's also a complement system. So this is 2. All right, in this case, there's a number of different factors that come together and form a membrane attack complex. And these also form pores like the defensins, but they specifically attack gram-negative bacteria. Okay, so that's it for serum or plasma mediators. The next category of chemical defenses are what we call cytokines. Cyto is cell, kinesis is related to movement. So these mediate cell-cell communication. So if you were to, for example, inject an animal with some gram-negative bacteria or just some cell membranes, or excuse me, cell walls, some gram-negative bacteria, the white blood cells then will produce a variety of factors that you can then isolate in the blood, including interleukins. Leukin is a reference to leukocyte or white blood cells. So these are produced by a variety of different cells, and they produce a variety of different responses. And by a variety of responses, I mean that some of them are related to the immune system and defense, and some of them are not related to the immune system or defense. The one that I'm most familiar with is interleukin 1, abbreviated IL-1. And mostly because there was a gentleman who recruited me to graduate school. His name is Dr. Matthew Kluger, who was working on this at the University of Michigan. Interleukin 1 functions as a pyrogen. All right, so if you were to inject bacteria cell walls into an organism, you're going to produce interleukin 1 and other things like TNF alpha. The interleukin 1 will go to the hypothalamus. Which is an important control center. Pyro means fire, gen means beginning or creation of, and so then you can hopefully deduce that interleukin 1 and other pyrogens, when they go to the hypothalamus, do something, which means they make prostaglandins. And then the prostaglandins are responsible for raising the set point for body temperature. And give rise to what you more familiarly would call a fever. It always drives me crazy when people say they have a temperature because, well, everyone has a temperature. It's usually 98.6. I've been taking my temperature quite frequently now with the coronavirus. Mine's usually a lot lower than that, like 96.8. 90, 97, 97.2. But anyway, so a fever is when you have a elevated body temperature above 98.6, and that's the proper term here. Not a temperature. Everyone has a temperature. Even if you're dead, you still have a temperature. It just happens to be room temperature. The significance of interleukin 1 and these other pyrogens communicating to the hypothalamus to make prostaglandins and raise the set point is that you can block the enzyme that's responsible for making the prostaglandins by NSAIDs, non-steroidal anti-inflammatory drugs like aspirin, ibuprofen, and naproxen. aspirin as in Bayer, ibuprofen as in Advil, and Motrin, and naproxen as in Aleve. They're very efficient at blocking prostaglandins and will cause your body temperature, if it's elevated, to go to 98.6 within about 20 minutes. Acetaminophen or Tylenol also does this, but not so well. It does, in fact, as advertised in the bottle, reduce your fever by a whopping 1 or 1.2 degrees. So it's not as efficient as these other ones. All right, so interleukins, a variety of different things. This is one that's talked about a little bit later in the chapter, page 770. And I figured, well, since fever is mediated by these interleukins, among other things, I might as well just say everything you need to know about fever now, and that means I won't say anything about it later at the end of the chapter. All right, so interleukins are the first cytokine you need to know. Second cytokine you need to know are the chemokines. These are what happen when you have a local injury, and what they do is they recruit leukocytes or white blood cells to a site of inflammation. Okay, so once you have an injury or you've identified as foreign material, the white blood cells in surrounding tissue release these things, and leukocytes will then migrate from the blood plasma and the blood across the capillaries into the site of the inflammation. The third and final type of cytokine that I want you to know are called interferons. Literally, we'll start out with the name. So these interfere with viral RNA biosynthesis. Okay, so that's everything I want you to know about cytokines and interferons. All right, the last type of chemical defense that I want you to know a little bit about are inflammation eliciting mediators. I guess the cytokines would, the chemokines that is, would fall in that category, but inflammation eliciting mediators. All right, and there are three, and these are going to be somewhat familiar to you. So one is histamine. Histamine is responsible for, in mucous membranes, watery secretion and secretion of mucus, irritation like cough and sneezes. Of course, in the case of poison ivy, histamine causes you to be very itchy in terms of irritation. The vessels dilate, and they become more permeable, which causes edema. All right, dilate meaning more blood flow, so you have redness. Because of the increased blood flow and the increased permeability, you have swelling, which you know as edema. Like around a mosquito bite. All right, second category, and these are really, really important, but I'm not going to say really a lot about them other than just to introduce them, are prostaglandins and leukotrienes. Prostaglandins mediate, among other things, contraction of the uterus, blood clotting, fever, as I just mentioned, and the enzyme that makes the prostaglandins and indirectly leukotrienes are blocked by specific categories of drugs called non-steroidal anti-inflammatory drugs. So these are lipids. And their biosynthesis is again blocked by those NSAIDs that I just mentioned. Aspirin, ibuprofen, naproxen, and acetaminophen not so well. All right, the third and final category of inflammation eliciting mediators is bradykinin. And bradykinin is kind of like histamine light, so rather than dilating the vessels and making them more permeable, it just does the light thing. It makes them more permeable. All right, now the most obvious sign of the increased permeability is going to be swelling because of the edema formation, but the main purpose of this is to allow your leukocytes, your white blood cells, your defense system to move more easily between compartments, between the blood plasma and the interstitial fluid, so that way your white blood cells can move into the tissues and take care of whatever type of inflammatory or disease process might be taking place there. All right, so that concludes this lecture series in terms of the chemical defenses that are nonspecific host responses.